Thanks to all who have joined today's CISL seminar series. The title of today's talk is International Consortium, Developing the Next Generation Earth System Grid Federation Distributed Data Infrastructure. And we're pleased to have Dr. Forrest Hoffman from Oak Ridge National Lab here to give this presentation. A little background on Dr. Hoffman. He's a distinguished computational Earth system scientist and the group leader for the Computational Earth Sciences Group at Oak Ridge National Laboratory. He develops and applies Earth system models to investigate the global carbon cycle and feedbacks between biogeochemical cycles and the Earth system climate. In addition, Forrest applies data mining methods using high-performance computing to problems in landscape ecology, Earth systems modeling, remote sensing, and large-scale climate data analytics. And these are all topics that are really of interest to us here in CISL as well as those across NCAR as we're trying to find new ways to really support data analytics capabilities at NCAR and across our community. So thanks for joining us today, Forrest, and I'll hand it off to you.
All right, thanks very much, Doug. I'm going to try to share my screen. Okay, can everybody see that?
Yep.
All right, great. Well, thanks for the introduction, Doug. I'm Forrest Hoffman at Oak Ridge National Laboratory and formed a recent collaboration with a couple of other laboratories to take on the modernization of their System Grid Federation. Doug already introduced me, but I was going to give extra points for anybody who recognized where this picture was taken. It's actually from Mount Evans on the way back from a CESM workshop up in Breckenridge a few years ago, before the 10-mile room collapsed. But as Doug mentioned, I've been at Oak Ridge for quite a while and am working on global Earth system modeling questions and trying to apply new AI and analytics methods. And I'm also a joint faculty member at the University of Tennessee. But I came to talk about the Earth System Grid Federation. So the ESGF is both an international consortium of infrastructure providers around the world and a globally distributed peer-to-peer network of data servers that are part of this infrastructure. They use a common set of protocols and interfaces to archive and distribute climate and Earth system model output, as well as now related input data, observational data that may be used for direct comparison with Earth system model output, and reanalysis data. These data are used by scientists all over the world, looking at the consequences of climate change scenarios from Earth system model projections, and trying to understand better Earth system feedbacks, like climate sensitivity. I just wanted to mention and reiterate that this is an international consortium, so there are lots of contributors all over the world, but primarily in the US and Europe and a little in Australia, where a lot of the development activities for the data backplane software are underway. But what are the data used for? Well, all of these simulation outputs are really part of CMIP or something related to CMIP activities. This coupled model intercomparison project that's part of the World Climate Research Program. Most of you will be familiar with these IPCC assessment reports. The 6th one came out from Working Group 1 on August 9th of 2021. On nearly all of the model output that's referenced in the papers that are subsequently cited and reported on in reports like this assessment report were performed at international modeling centers like NCAR and stored and distributed for use by scientists who did the analyses via the Earth System Grid Federation. So these data are important, right? They're very important to us. They are about the future of life on Earth. It's hard to get more important than that. The holdings, of course, are large and growing. So CMIP5 produced about 5 petabytes of data, as you can see in the sort of middle blue tier there. Cortex activities are going on now, so that's downscaling of CMIP5 and CMIP6 results. CMIP6 totals are nearly 26 petabytes. That includes some replicas. So we estimate that it's on the order of 15 petabytes of single copy data, distinct data sets. So that's fairly large and getting bigger. For CMIP7, there's a lot of discussions right now in various CMIP task teams and in the CMIP panel about the potential sizes. And they're currently estimating that single copy unique data sets are likely to achieve on the order of 100 petabytes of data. So globally, that's quite a bit of data. Some of those data are also collected and archived in local regional hubs, and I'll talk a little bit more about that in a minute. One of the objectives of our new project, of course, is to expand these holdings to try to make room for and build out additional data sets that are of interest to the community. So we formed a new consortium project a couple of years ago between Oak Ridge National Lab, Argonne, and Lawrence Livermore National Lab. And we proposed to modernize the data backplane and to borrow heavily from capabilities in the Globus platform. So we submitted a proposal that was reviewed in August 2021 and selected for funding by DOE and that's actually started last fiscal year. So in collaboration with our international partners, primarily in Europe and Australia, the project is developing and deploying new architecture based on a future architecture roadmap that was actually written before we formed our new consortium. In addition, the project intends to build out some new data discovery tools and data access interfaces, bring on board server-side computing for subsetting and summarizing data sets in an automated fashion behind the scenes. This is something that ESGF has been thinking about and promising for a long time, as well as delivering user computing capabilities. So things like Jupyter Hub environment where people can get on and access the data all at the same time very easily with an API, and improved user and system metrics so that we can track better what data are of interest, what kinds of queries are being made by different users, so that we can do a better job of staging data, moving it around where people are going to want to use it, and understanding how people are accessing it better. As a part of our project, we've added a couple of advisory groups that I'll tell you a little bit more about in a minute, as part of the governance to help us really direct and prioritize our efforts, as well as adding our intention to have a help desk and user support. Right now, if you have trouble with ESGF, you send an email out and somebody may or may not answer it depending on how much time they have. This is a view of DOE's US-centric look at their System Grid Federation. You can see that on the global internet down at the bottom, there are lots of data nodes that are scattered across the planet. But within the DOE enterprise, the primary server sits at Lawrence Livermore National Laboratory, and it attempts to replicate data, primarily data that are at daily or lower frequencies from all other nodes, so that we have regionally in our area a copy that we can get to really quickly to do analysis. In addition, there's an independent data node operating at Argonne National Laboratory. But there are also diamonds on here for GFDL and NCAR and JPL, all of whom also operate ESGF nodes here in the US. Our view and our plans for building out are to have as many as 3 nodes that are co-located at DOE's major computing facilities. So that's at Argonne National Lab, at the Argonne Leadership Computing Facility, Oak Ridge National Lab at the OLCF here, and potentially out at NERSC or at Lawrence Livermore National Lab, very nearby NERSC with high-speed connections. And we would continue to attempt to replicate data from the larger global federation. We would also start using cloud-hosted indexing instead of trying to replicate Solr databases across all of the index nodes all over the world, which really doesn't work out very well. But we think the technology has really evolved for using these kinds of scalable databases in the cloud, where we can dynamically provision the resources necessary to respond to requests. So that's something that we want to add. And in addition, we want to do some data replication among sites and add tape archiving for data. Right now, the way the nodes are operated, that's not the case. All of the data, at least for these DOE systems, is kept on spinning disk. As a part of our development activities, we want to base things on open architecture and protocols so that we can easily substitute alternative implementations in and out. And we may find that partners in the larger federation are interested in different kinds of implementations of open standard protocols. And so we want to enable that kind of capability so that everybody isn't necessarily running the exact same software everywhere. That takes a little more work, but we recognize that. We want to leverage highly available and scalable central services through Globus. So we think this will help us reduce complexity and increase reliability and provide some economies of scale, since Globus is handling many of those services already for various other kinds of data infrastructure. We want to use proven and modern security technologies and practices. So we want to have integrated access control that's distributed and build up our technologies for protection against attacks and intrusions and data munging. In the design, we want to have a use case approach so that our implementation and evaluation is based on real user needs and ensure that the solutions are meeting those needs. We want to have integrated instrumentation so that we can collect metrics that will drive our data management efforts and the data access features and capability development that we deploy. And of course, we want to focus on performance to deal with this ever-growing set of big data. So we want high-speed data transfers, really efficient search capabilities in this enormous database, this big index of all the data that we have for these modeling and comparison projects, as well as offer server-side processing that can operate really quickly on subsets of the data archive. So we've thought up some of these kinds of potentially typical use cases where, for instance, we may have a user logging in with their institutional credentials instead of our providing that authentication. And so then Samantha is presented with a bunch of new data and code, as well as supporting papers relevant to her current research. She finds an interesting report on extreme precipitation events and looks at a Jupyter notebook that implements the methods that were used in that paper. So she's interested in how that method might work for higher resolution data from another Earth system model like E3SM. And so she locates the required data sets and runs the notebook on that subset of simulations and finds that the results are promising. So she shares them with collaborators via a federated storage capability through ESGF, and they agree that a larger ensemble analysis may be needed. So she finds the full ensemble data available, for instance, at the Oak Ridge Leadership Computing Facility, and submits a request to execute an analysis there. And then within 24 hours, the results have been published in ESGF for broader consumption, along with a notebook that was used to produce and validate the results. So this is a kind of use case that integrates analysis and modeling simulation capability and leverages a lot of the technologies like Jupyter and GitHub that are already available for people that people are already using out on the wider internet. And so this is the kind of use case that we want to try to target and provide the middleware and infrastructure to support. We work closely with ESNet, the Energy Sciences Network, and the idea there is that we have some high-speed links over to Europe, primarily for high-energy physics experiments, but we get to take advantage of that high bandwidth between DOE labs and other HPC centers and big experiments. So maintaining this connection with ESNet is really important for us, and they've been very helpful in optimizing communication across the wider internet for data exchange. As a part of the project, we'd like to, as I mentioned, focus on open standard protocols, but we'd like to build out new data discovery user interfaces. The current user interfaces that we have are all kind of multifaceted search, where you need to really understand a detailed, controlled vocabulary in order to request data. And what we'd like to do is to make that a lot easier. These Earth system model outputs are being used by a broader community of stakeholders, including the reinsurance industry and the financial industry, for better or worse, whether they were really meant to provide that kind of information or not. But we would like to make it so that people can really utilize these data to the best of their capabilities. So we need to provide much more functional interfaces. We need to provide graphical preliminary results that they can look at, even small icons. We need to provide some background information on model intercomparison papers that have been produced and benchmarking results. And so those are the kinds of things we're talking about adding to a data discovery platform that users could then use to access the data. We also want to have multiple data access methods. So we already have HTTPS supported. It's visible via OpenDAP, so people can just come in and look at the data that way. We're working on right now a full deployment of Globus, so that you can go into even the current user interface and request a bunch of data, and then just point to the machine where you want it to be located. And then once it's all moved for you transparently and independently of anything that you do subsequently, you'll receive an email that says that your transfer is done. You can go log in to Ratio or wherever you sent the data, and it'll just be sitting there in your account. We want to also add more outreach activities. So, there's been a lot of challenges in using prior versions of ESGF, and we want to have sort of a double-pronged approach to dealing with this. We want to improve those interfaces, but we also want to do more education, providing webinars, tutorials, and boot camps, both for the user-facing part of the system, so that people can better understand how to use it, but also for the management and operations of ESGF nodes. We've already started a webinar series for ESGF, and you can go out to YouTube and see the first of those presentations that's out there. We've actually had 2, and I'm working on getting the second video posted soon. And we're also interested in people who would like to give some of these webinars to talk about their experience with ESGF or present results from CMIP data. We're also thinking about hackathons and workshops that might focus on data standards, helping new sites set up data nodes and user compute services, and then holding tutorials and workshops at scientific conferences like AGU, EGU, and AMS. We also want to bring back the annual ESGF developer and user conferences that were held for some time before the pandemic. And we actually held one that was held as a dual hybrid kind of conference in the US and in Toulouse, France at the same time. So we had a cross-Atlantic sort of hybrid meeting, and then other people joined in a hybrid fashion as well. But we were able to get together sort of as US and European teams to talk about future developments and some of the activities that we have ongoing. This particular conference was more focused on development activities, given that there have been so many changes in ESGF that were kind of between CMIP activities, and since the pandemic had really cut off a lot of communication and collaboration that we'd had going previously. So we expect to do this on an annual basis. A little bit more about the organization. So ESGF is governed by an executive committee that you see in the lower left of the figure, right? And that consists of people from various modeling centers or data centers that are distributing the data, and really is mostly led by folks who are doing new development on ESGF. That group meets every month so that we stay in good communication. And then the ESGF steering committee sort of sits above the executive committee. They meet far less often, but it's composed of primarily representatives of sponsoring agencies like the Department of Energy and NOAA and NASA and EasyNess in Europe, and the National Computing Infrastructure in Australia. As a part of our project, and you can see most of the staff, most of the personnel involved in our project in that middle box, I mentioned that we added this resource and project liaison group. The purpose of that group is to sort of enhance our communication with projects that are critically dependent on the infrastructure that we provide, or that provide similar kinds of infrastructure within the Department of Energy. Or they're part of critical resources like ESNet. So you'll see Eli Dart's name up there as a representative of ESNet, so that we're, engaging groups like them who are helping us by providing some critical resources. We also added a science user and facility advisory board to help evaluate our efforts and prioritize future developments, particularly with a focus to user community needs. So you'll see there a couple of folks from industry, like Tyler Erickson, who was until very recently with Google Earth Engine, and Kate Marvel, who is a climate scientist, but now with Project Drawdown, as well as folks at laboratories and universities, and Jerry Meal there at NCAR is a part of this advisory board. I also wanted to give you some information about some recent work that we did as soon as the project started up. So recognizing that really the U.S. DOE data are all kind of located on spinning disks only at Lawrence Livermore National Lab, and that includes the replicated data from the larger ESGF. We decided that we needed to make a backup of that, and so that was about 7.5 or 8 petabytes of data that we transferred to both Argonne and Oak Ridge simultaneously using Globus over ESNet. So there was a good amount of scripting that had to be done, ESNet monitoring and diagnostics, a lot of optimization work on data transfer nodes, and optimizing communications for GPFS file systems, and a lot of debugging and problem solving. So we got kind of a slow start. We also recognized that the number of DTNs at Livermore is much fewer than at Argonne and Oak Ridge. So we were kind of limited to 1.5 GB transfer out of Livermore. So the data out of Livermore traversed that link only once, and either went to Argonne or Oak Ridge, depending on which system was up or down. And then the Oak Ridge and Argonne machines could sync together much more quickly. So between mid-February and May 4th, we transferred about 17 million directories and almost 29 million files. And you can see that we got kind of a bumpy start down here in February as we were figuring out how to get all this going. But by March 1st, we were chugging right along and sending CMIP 6 data. until about mid-April, and we backed off to the CMIP5 data. We encountered then some GPFS errors, some unreadable files, so that the data directories were kind of dirty and had some gibberish in them, and so we had to clean some of those things up. And we also needed to reconfigure GPFS because the data for CMIP6 are typically in much larger files, but for CMIP5 files were much smaller, and we started to re-optimize that, and then we very quickly finished transferring the rest of the data by the 1st of May. Interesting stats. So I love these kinds of stats and stuff. So it's very interesting to look at like the transfers between the 3 laboratories. And you can see that in blue that the Livermore, well, and orange, that the Livermore connection is pegged at about 1.5 gigabytes a second, sometimes getting close to 2. But the communication between OLCF, the Oak Ridge, and the Argonne Leadership Computing Facilities gets much higher. And actually from OLCF to ALCF, we actually got occasionally 7.5 gigabytes a second of throughput, which is not bad. And we didn't do anything else. So all that while, these data transfer nodes are also being used by other parts of the community, moving data around, the high energy physics people and nanomaterials, et cetera. So there was there was no special tests done by shutting down any of the other activities that were going on. Before I wrap up, though, I wanted to talk a little bit more about sort of what DOE does. So DOE has a few data centers for the work that it does, but is very interested in ensuring that we have open and accessible data, and that the work that we do is available to the rest of the scientific community. So as a part of the Atmospheric Radiation Measurement Program, which some of you may be familiar with, they have a very large data center that's actually also located here at Oak Ridge National Laboratory. The Giri Palanisamy or Prakash, who is part of, who leads that activity, is also part of our ESGF activity. And so we'll be leveraging some of the work that they've done as well for our data center here at Oak Ridge. But they have a very nice data search page and multiple ways to find ARM data. They have about an order of magnitude smaller data than what we've got sitting on disk now, but it's been collected over a much longer period of time, and it, of course, is much more valuable because the majority of it is observational data. And so they want to, they also do a good deal of work on ensuring that data quality reports are there, and an ancillary metadata is included with those data. A more recent data center that's part of DOE is this ESS Dive, or the Environmental Systems Science Deep Insight for Earth Science Data, which is located at Lawrence Berkeley National Laboratory. So they collect and archive data that's a part of various field activities that are conducted within DOE and funded by the ESS program. And so as a part of all of those field activities, they have to provide their data and get it archived here in ESS Dive. Unlike ESGF, they have many more kinds of formats and different kinds of data than we typically do in dealing just with model output. So they have some more interesting challenges, but again, they're typically much smaller data sets than what we're dealing with from the model. So to wrap up, this next generation ESGF, we hope will be designed for an order of magnitude increase in data sizes. That means it needs to be highly available, scalable, and fast. We want to build in mechanisms to automatically migrate data as needed so that we can stage it, just like Netflix does when a new release is coming out, right? And they stage their those movies in data servers that are close to the consumers when they're going to be watching them. We want to automatically do that migration, and we want to improve data discovery and sharing tools so that it's more accessible, and offer the server-side computing and derived data products that we've all wanted for a very long time. and offer user computing capabilities so that the users can get an allocation and compute near the data. Basically, they can sit down and do an LS on all the CMIP projects simultaneously, and then imagine the kinds of analyses that they can do. All the new development, of course, is being performed collaboratively. This slows things down, but also speeds things up because we get a lot of help from our federation partners all over the world. They all bring their own funding and their own interests too in what they would like improved and enhanced. But we coordinate that development so that we're working collaboratively all the time. Our project aims to also add new data projects to support large-scale artificial intelligence and machine learning data. A lot of the training data we expect to be very, very large, like the model data. And so we want to be able to provide a source for that kind of training data. And for things like multi-agency model intercomparisons, large ensembles, those kinds of things, model benchmarking, where we have a lot of sort of rewritten and re-optimized reanalysis or other kinds of observationally constrained data that we would use to evaluate models. And then we think the user computing approaches that really have been initiated in the commercial cloud would be another way of sort of delivering the data to users. So we want to ensure that the commercial cloud can be used, but also that we can deploy our own on-premise cloud infrastructure to facilitate that kind of research. Yeah, so that's what I've got on our new project activity. I'll be glad to take any questions.
All right, thanks for the presentation, Forrest. Virtual round of applause by the audience that I can see. So next we'll go to questions from the audience. Please raise your hand if you have a question, and otherwise you can add it to the chat. But to kick it off, looks like Brian Dobbins has a question. So
yeah, hi, Forrest. Thanks for the talk. This was really interesting. I'm curious if you could comment on the time frame for ESGF2 being operational, and on a technical question, what is the approach you guys are looking at for doing like spatial subsetting of data or temporal subsetting of data? I'm just curious about the technology stack there.
Yeah. So let me start with the full new data backplane. We plan to do this kind of incremental implementation. But what we're doing right now is standing up a node at Oak Ridge that will have all of the functionality of the node at Lawrence Livermore National Lab. We're deploying this new user interface called Metagrid, which you can go out and play with right now on the Livermore server. But we hope to have all the pieces in place that we've described here, at least some fundamental capabilities available within the next 2.5 years. And we're hoping that it will all be there before any subsequent, any substantial amount of CMIP7 output is stored in the ESGF. With regard to technologies for that server-side subsetting, we've talked about various kinds of things like WPS services, this kind of web processing service. So we have a compute working team that's actually joint with our infrastructure collaborators in Europe that are trying out a number of these technologies right now for that kind of subsetting and processing. We think a lot of existing Python codes will be really useful for doing this, and we're just trying to get right now that hardware in place so that we have big empty disk stores so that we can move that data around and create these subset products.
Got it. Thank you.
Mm-hmm.
John Klein.
Yeah, thanks for the talk, Forrest. I'm curious, NASA and NOAA and other agencies have made a decision to move their data collections, or many of their data collections, to commercial and public cloud. And ESGF seems to be more of a traditional on-prem data center focused approach. I just wondered if you could maybe comment on the decision process there, if commercial cloud was considered, and maybe also talk about what, from a user perspective, who might be wanting to pull data sets, access data sets from multiple different sources, what kind of barriers in terms of compatibility they might be facing, or what's been done to facilitate that access.
Yeah. So we have a couple of projects in ESGF that are involved in having some subset of data out in the commercial cloud. So there is some at Amazon AWS through NOAA, who's part of ESGF. And then, you're probably also familiar with the Pangeo effort. And so we've tried to help facilitate that. And we see that as, a delivery mechanism, but not the primary delivery for the data, because as a federal agency, we do have to ensure that we have sort of a zero copy of all original data. And I'm sure that NASA and NOAA must be doing that as well, either contractually through the commercial cloud or through some other mechanism. But of course, our objective is not to necessarily help other people sell computing services. And we have, we actually have these large data centers that we're deploying anyway. And so that really, I think, changes the equation within at least the DOE space about how and where to provide that kind of computing capability with very high speed interconnects and lots of computing in these computing centers where the U.S. has decided it wants to build out sort of bleeding edge HPC. We are basically trying to leverage that, those capabilities, and provide this to the user community. But again, we think commercial cloud is a fine way to do that. And one of the objectives I maybe didn't mention was that a lot of the APIs that we want to build are going to be contained in, I think I did mention Docker or other kinds of container services. So we hope that people can just take them to the commercial cloud or their university cloud or their science program team cloud systems and still be able to use them the same way as they would on, for instance, the on-prem cloud that we're talking about building.
Thank you for that.
Tasia, you have your hand up.
Yeah, there's a question in the chat from Tom Cram. It says, can you talk more about the technology used for search and discovery? For example, are you using Globus Search or something else?
So we are experimenting now with Globus Search. We think that, and Globus Search is kind of built based on the Amazon implementation for Elasticsearch. And so those kinds of technologies are what we think we want to go to. And we definitely see the cloud and the commercial cloud as the place to do that kind of functionality. And so that's what we're looking at potentially deploying either through Globus Search or directly with Elastic in the next generation system. But right now we're still based on this old Solar database technology and just trying to get off of that as quickly as we can and figure out how to integrate that across the US capabilities and the European capabilities and the Australian interests, because they all have additional data products as well. So they'll need to have not necessarily a copy of that, but the ability to look at multiple indexes to service the searches that are conducted on their various sites.
Any other questions from the audience for Forrest? If not, I have a quick one. So you talked about how that, the data proximate compute capabilities such as Jupyter hubs will be located at DOE and other facilities. So as a user who has access, who is eligible to access those compute resources once they're
we haven't addressed that question yet. We hope that we have a problem like that it's become so popular that we have to go through some kind of allocation mechanism. And then we'll do something like what NERSC and the supercomputer centers do, and have people apply for time on those systems. But with the exception of a short list of countries, we want to make it widely available to even the international community. We'll have to figure out how to do that, but we're locating this infrastructure in an open network enclave that's part of OLCF here at Oak Ridge. We'll be doing the similar thing in other places, so that we have a sort of light way of providing user authentication and access to those kinds of environments.
And then, NCAR runs a legacy ESGF node. What's the role for NCAR in the future with ESGF2?
Yeah, I think it's up to NCAR, but I'm certainly hoping that, Gary Strand has been a great partner and a great advisor for a long time for ESGF. But I'm hoping that NCAR and CISL will, adopt the same kinds of new technologies. And I would really love to interact with you guys on what else we can do to help facilitate what is basically our joint user community. And going forward. So I know there are a lot of large ensemble work that's going on at NCAR, and providing another outlet or another storage and archive location for some of that work would be great. Being able to have E3SM output more easily available at NCAR, I think, would also be good. So I'd love to find a way that we can have some special, interactions for those kinds of regional activities in the future.
Okay, thank you. One last call for questions. And if not, we'll thank Forrest for today's presentation, and thanks to everybody for joining. It was a good talk. So thanks for the information.
Thank you very much.
Okay, everybody, we'll provide information about the next CISL seminar series event once it becomes available. And thanks again, Forrest, and have a good afternoon to everybody.